All right, so today we're doing 5.2.1. I know it sounds like it's out of order because we haven't done 5.1.2 yet, but this makes more sense to go with this, and then we'll go back to the other stuff in a second or tomorrow. So we're going to verify trig identities. This is going to be very, very, very similar to what we did on the last video. So the first example here, the difference between verifying and simplifying is we want to get both sides to be the same. So instead of having just one thing you're simplifying down, now you know what the answer is. It gives you a thing and then something you're supposed to equal. You want to get them to be the same. So if we look at this using what we did from last time, I'm going to start by writing everything in terms of sine and cosine. So we have sine of x plus cosine of x times cosine of x over sine of x. And we all want that to still equal cosecant of x. So in general, you start with one side and work your way down. You can do both sides, but I would say to start with one, simplify, hopefully they end up equaling the same thing. So if we keep going, we get sine of x plus cosine squared x over sine of x. At this point, I'm going to get a common denominator. So I'm going to multiply this by sine of x over sine of x. You then get sine squared of x plus cosine squared of x all over sine of x. And then if you go to your trig identities sheet, I have mine here up in the top corner of the Pythagorean identities. We're going to use that first one and get 1 on top all over sine of x. Using your sheet again, you can look at the reciprocal identities and you get cosecant of x here, which is the same as what we wanted. So you're done. You've verified it. You've shown that this is true. You do get what you want to get. So, some guidelines for verifying. First, start with one side of the equation. Usually it's easiest to take one side, transform it into the other. Sometimes you can work on both sides, but you shouldn't need to. It's usually easier to start with a more complicated side. Later on, we'll get into some details of when it's not, but in general, start with the complicated side, make it look like the simple side. And then use all the same tips from yesterday. So like know your trig identities, change things to sines and cosines, find common denominators, all that kind of stuff. So some more examples. If we're going to verify this one. So you have to decide which side to do first. This one looks more complicated, so I'm going to multiply this one. We're going to start by finding common denominators. So multiply this by 1 plus sine, this one times 1 minus sine. So this is just going to keep coming down the whole time. So we'll do equals, you get 1 plus sine of theta minus 1 minus sine of theta all over 1 minus sine theta times 1 plus sine theta. Here, this parentheses are important at this point because we haven't distributed the negative yet. So if you don't have those parentheses, you're going to end up subtracting sine instead of adding it. So this will then give us 1 plus sine theta minus 1 plus sine theta. If I multiply out the bottom, you'll get 1 minus sine squared theta because your negative sign and positive sign will cancel out. So here at this point, your 1's cancel. We get 2 sine of theta on top. And then the bottom can become cosine squared theta using your Pythagorean identity. So again, right here, rearrange the first one and you get cosine squared. So I'm still trying to get this 2 tangent and 1 secant. So I'm going to rewrite this and break it up and get 2 sine theta over cosine theta times 1 over cosine theta. So I'm breaking up the cosine into 2 chunks, which then becomes 2 tangent from there and secant from here. If we scroll back up, that's what we wanted. So we can bring that down and it worked. For these on homework and tests and all that kind of stuff, you need to show every step because you know what the answer is supposed to be. You know you're supposed to get to this. So if you don't write all your steps, you're not going to get credit. Another example here. So you can decide what side to start with. Since they're both kind of similarly complicated, I'm going to start with ones with secants and tangents and change that into sines and cosines. So you get 1 over cosine plus sine over cosine. So this is handy. We already have a common denominator. So you get 1 plus sine of theta over cosine of theta. And then here you might be stuck, like, well, what do you do? So I know in the end I want to get a 1 minus sine theta on the bottom, but I don't have that yet. So I'm just going to put that in. I'm going to multiply this by 1 minus sine theta over 1 minus sine theta. And with these, there's not like one way you have to do it. There's usually one way that's faster, easier, but there's never like only one way. So if I FOIL the top out, you get 1 minus sine squared theta. And then I'm going to leave the bottom not FOILed out for now. Okay. The top becomes cosine squared theta, again using the Pythagorean identities in the top right of your sheet. And we still have cosine theta 1 minus sine theta. So I can cancel this cosine with one of these. And then you're left with cosine of theta on top and cosine theta, sorry, we don't have this second cosine theta down here. 1 minus sine theta on the bottom. And that's what you wanted. So now you're done. So I believe this is the last example. So looking at this one, you want to decide what side to do. Again, they're both kind of similarly complicated in terms of fractions, but I'm going to start with this side because it has tangents and secants versus sines and cosines. So we'll move it over here so I have more space. I'm going to rewrite this as sine squared theta over cosine squared theta. You could also do other things, like you could rewrite this as secant squared minus 1. That would also work. I actually might do that option. So I'm going to rewrite this as secant squared of x minus 1 all over secant of theta minus 1. So then at this point here, we have a difference of perfect squares. So you could factor this out and get secant of theta plus 1, and then secant of theta minus 1. And then here this will cancel with this. We get secant of theta plus 1. And now we want to get into our cosines. So I'm going to rewrite this as 1 over cosine of theta plus 1. And then to combine and get common denominators, this can be multiplied by cosine of theta times cosine of theta. We'll get 1 plus cosine theta on the bottom and cosine theta on the bottom there. And that's what we wanted. And that's done. So again, there's more than one way. You could have turned this into sines and cosines, so done sine squared over cosine squared on the top, 1 over cosine minus 1 on the bottom, and then combined, gotten common denominators, multiplied by the reciprocal, that kind of stuff, and it still would have worked. So there's always more than one way. Again, here's your assignment. Check Schoology to see what's taken out and what's not. If you have questions, go on the Zoom call. Let me know. There's a key that you can check as you go through stuff.